The importance of sustainability is growing. I think that the conversations that we've had over the last couple of days with regard to the consumer's desire to understand is sort of the backdrop. I think the last couple of questions about traceability being a backbone really for information flow is key to the connection with sustainability. I want to give a sort of a high-level background overview of my view of sustainability and why it's important. A lot of this will not be new. The first few slides I've borrowed from the Rocky Mountain Institute and talk about natural capitalism and sort of where we are today in the conversation around sustainability. So capitalism can be defined as the productive use and reinvestment of capital. There's multiple flavors of capital, if you will. The financial capital, goods, the infrastructure that enables us to transport goods and services, provide goods and services, human capital, obviously, and nature. Ecosystem services in particular, without which all of the other stuff really ceases to matter. And so this idea of stewardship and the agricultural mantra for millennia, really, about maintaining soil health, maintaining the ecosystem services, enabling the provision of food, really, in my mind, underpins the entire global economy, including auto manufacturing and everything else. Because without it, we're in deep trouble. The first industrial revolution was based on the notion that people are scarce and nature is abundant, right? We had almost an infinite supply, or it seemed like an infinite supply of resources. And through the Industrial Revolution and, machinery being brought to bear, we've been able to increase the productivity of people by 100-fold. So the next revolution, and I'm not exactly sure it's an industrial revolution, is sort of the counterpoint to that. People are abundant and resources are scarce. So what do we do What do we do then? We have to improve or increase resource productivity. And I think all of the efforts around sustainability can be sort of viewed through the lens of we have to do more with less. We've heard that phrase many, many times. So in the future, the things that are going to limit us are fish, not boats. So we have enough of the other kinds of capital to be prosperous, but our natural capital is beginning to be deplete, and we have to be able to manage and measure and move forward with increased productivity, increased resource use efficiency. So how does this connect to traceability? So one of the things that I find really fascinating is that we know that agriculture has a huge land footprint, something like 70% of agricultural land, both highly productive land as well as marginal lands, right? So all agricultural land, about 70% of it is dedicated to support livestock. Livestock consumption is growing, as shown from FAO data. Swine and poultry growing much more rapidly than the others, but cattle are also on a slight but steady incline, even though perhaps in some of the developed countries the consumption of beef is declining. Globally, it's increasing. And so we have to be able to manage the resource land very efficiently and effectively, or we will have serious problems come 2050 when another 2 billion people are coming to the dinner table. So I would submit to you that without measures and metrics, we cannot maintain and continuously improve our sustainability and security of the food that we produce. This requires the access to and collection of very high quality data, and in particular with regard to what I'll talk about in more detail a moment from now is lifecycle assessment. we need to understand the material and energy flows associated with every stage in the supply chain. And ultimately, I think this has been mentioned a couple of times in the past, this transparency, these data that we have may ultimately be tied to the social license to operate. We've talked about trust of the food system being not as high as we'd like it to be, and that people don't know where their food comes from, but they want to know. And so this framework of sustainability, and from my perspective, lifecycle assessment is a nice integrating framework to begin the discussion and educate people in the community. So what is sustainability? I've sort of made a simple modification of the Brundtland definition you may be familiar with, simply living within our means. And so in order to do that, we have to continuously improve our resource use efficiency given the state that we find ourselves in today. The sort of corollary to that is that we must enable future generations to equally provide for themselves. Given the recognition of resource limitations, we have to have measures and metrics to monitor our progress, to benchmark where we are, and document that we are making improvements, or we will fail future generations and hunger will increase. And we just, I mean, from a geopolitical stability perspective, we really can't afford to have significant increases in global hunger. And so the idea, all of the conversation around export markets and the sort of the breadbasket that the North American production systems represent is really critical, and making sure that those markets remain open and available is also really important. So lifecycle assessment is a holistic tool. It's an accounting tool, if you will, for keeping track of environmental impacts associated with, can be anything, but in this case, animal-sourced foods. And at the end of the day, it really will rely on traceability in the supply chain, knowing what was used where, how much of what was used where in the supply chain, what was lost in the supply chain, how can we mitigate those losses will become very important. Obviously, disease prevention that we've talked about quite a bit in this conference is really important. One, and it prevents people from getting sick, right? And in terms of sustainability, a sick person is not a good thing. And so all of the abilities that we have to trace that back and keep the bad foods or the infected foods off of the shelves and identify the sources is really critical, and plays a role, or plays a part in the sustainability. These and other human health benefits are poorly captured in life cycle assessment. And so I'm really excited about the opportunity to sort of bring these things together, the traceability, understanding the risk associated with diseases and transmission of diseases into the framework of life cycle assessment. So I want to give a few slides to you about LCA to kind of tell you what that framework is. There's a set of international standards that define how LCA should be conducted. It's composed of 4 stages. The goal and scope stage, why are we doing the study? This is always a good question to ask for any research project or other project for that matter. The inventory stage, what are the material flows and energy flows? What happened where along the supply chain? Addressing the impact, so in terms of greenhouse gas emissions, I'm sure everyone has heard the carbon footprint. I saw some slides up there a few minutes ago with the foot and 100 grams, perhaps from the Tesco study in the UK a few years ago. So understanding how all of the emissions that occur every place along the supply chain impact the environment is important, and the LCA community has developed tools that allow us to collapse all of that, sort of to integrate across the supply chain and give a number or a score, if you will, to each of these impact categories. LCA is used for product development. It's used for identification of hotspots where we can innovate, where are inefficiencies in the supply chain, how can we improve those. It's used for benchmarking so that we can document continuous improvement. It can be used for product labels and for market access as well. And in fact, it can be used in terms of addressing public policy. You may recall when ethanol was first being promoted, there was a a bit of concern about indirect land use, and so the effect that increasing production of ethanol in this country had elsewhere in the world. The Lifecycle Assessment community is are the ones that first pointed that out. And so understanding how the policy actions affect sustainability is also important. So the building block, if you will, of LCA is a unit process. This would be the place in terms of traceability where key data elements would be captured. And so in terms of capturing information that could piggyback on the backbone of traceability, we would want to know what materials were used, what was fed, what was the feed conversion ratio, for example, of a fish or a cow in a particular location, and what are the emissions associated with that operation. So for crayfish, for example, there could be methane emissions because it's an anaerobic system, or in cow-calf operations, methane emissions. Transportation, we would have particulates and those kinds of things that we would try to keep track of. And so those would be the types of data that we would like to collect. The unit processes all get built together into a rather complicated supply chain. This is a simplistic view, but each of the black arrows in the diagram that connect the unit processes could be considered a critical tracking or critical traceability event in which place we would capture that information and then have it become available, again, with some transparency, but a controlled level of transparency so that proprietary information can be protected. We have impact assessment methods developed in the LCA community, and without getting into too much detail, on the left, it's my left as well, on the left-hand side is the sort of the measured stuff, right? So the things that are connected to the traceability backbone, where we have documentation about the feed, the quantity, characteristics of the feed. We know information about the enteric methane. Perhaps we have a mathematical model that has told us something about the nitrous oxide emissions associated with field application of nitrogen fertilizers, et cetera. So we have very high confidence in the left-hand side. As we move towards the middle, you'll see somewhere down towards the bottom, third from the bottom, global warming. You may know that that's also known as the carbon footprint. So the IPCC has, 75 or 100 chemicals that can be emitted in commerce that have global warming potential. We add all of those up and we say this is the carbon footprint. And so we don't have to keep track of, we can integrate across the supply chain using this tool to see a smaller range of things that we care about. And those can be further collapsed into what we call endpoint categories. And as we move to the right on this diagram, our ability to make decisions and to communicate and to educate consumers improves, because it turns out that most people can't juggle trade-offs of more than 4 or 5 different things, right? So if you've got 5 things that are somehow in conflict with one another, you can't really manage the decision across what should I do? How should I operate my business? Or what sourcing, what product should I purchase? We simply need to have more aggregation of these impacts so that we can have a better ability to make decisions. Of course, to Mark's comment about the level of information that people use to make decisions, there's more uncertainty as we go further to the right in this. But it is much easier to communicate. So this is a truncated version of a supply chain, kind of typical to what we'd find in a life cycle assessment study. What we find very soon is that some pathways are more important than others. I'm not sure that we can apply the traceability to this complicated of a network. I don't know, right? So it's an open question as to how detailed that backbone can become, but using a tool like Lifecycle Assessment, we can see what are the pathways that matter the most, and we can try to target our efforts towards understanding the traceability and transparency of those particularly important parts of the supply chain. So that's the introduction to LCA. I think it provides a very nice framework for the conversation around sustainability. It has a very strong and I believe synergistic link with traceability. I'll spend the next few slides just to give you an update on some work that we've been doing at the University of Arkansas for NCBA, updating the study that was published in 2011 on the lifecycle assessment of U.S. beef production. The first version was based on a rather small set, well, to be frank, a single farm. And what we've done is been working with Al Rotz at the USDA in Penn State, and he's collected a lot of demographic information across these different regions in terms of how our beef operators managing their herds and what are the characteristics of those production systems. So we've tried to break it up so that we have different climatic zones that are accounted for, and then all of that information is going to be combined together through simulations, right? So we had some experience with the dairy sector where we sent out a survey, and we discovered that surveying farmers is hard. To the dairy sector's credit, we sent out 5,000 surveys and we got back 540. Yeah, and the fact that the survey was 20 pages long and took between, yeah, right? It was 20 pages long and it took between 6 hours and 4 days for them to gather the data. I had a guy say, "Weren't you disappointed with only 10% response?" I thought, "Are you crazy?" That was incredible. So what Al has done is he's made a fairly truncated set of questions, and he's been contacting a lot of farmers, and they've got a web-based opportunity to provide information. So what we do then is take that and we put that into a mathematical model that Al has constructed over about the last 20 years, and there's a cartoon of it on the slide here. You can see that it accounts for virtually all of the activities that occur on a farm. So we've simulated the farm and collected the data, run the simulation models, and then we're going to aggregate those into the regional data will be aggregated into national data. And the middle bullet on the left is the main activity that we are doing at University of Arkansas, taking the output of these simulation models and linking it with the full supply chain model. So in that complicated red diagram, the farm could represent maybe 3 or 4 of the boxes on that supply chain, and we connect that to the rest of the economy to give a full cradle-to-gate assessment of the environmental impacts associated with the production. So we have data from 5 farms. These are all cow-calf finisher farms. So they're fully integrated, where the feedlot is on the same facility as the cow-calf operation. And you can see that the area ranges from about 100 to maybe 400 hectares, differing amounts of pasture, different quantities of alfalfa, corn, silage, how much is grazed, number of cows, and then the bottom row shows the productivity on a per hectare basis. And so there's some difference across the farms in terms of their characteristics. But for me, the most fascinating thing is that, and I think I'll skip this slide because I might come back to this slide, but I'll show you this slide, contribution analysis for greenhouse gases, right? So everybody is aware, I assume, that beef is one of the highest carbon footprint animal proteins. I don't think that's a big surprise. What is a surprise is that we see almost a factor of 2 difference between farms in the same region using fairly similar production practices. And the horizontal blue arrows there highlight what's driving the difference between farms D and E and the first three, and it's grass pasture. And so naturally, I'm curious about why that is, and it turns out to be driven almost entirely by nitrous oxide emissions, which are in turn associated with soil type. So the farms that have the higher nitrous oxide emissions tend to have two things happening there. One, there's a higher clay content in that soil, which increases N2O emissions, and they're in slightly warmer parts of the region, more towards the south of the upper Midwest region compared to the farms that are in the Wisconsin area. And what this tells us is that traceability matters, right? If we want to be able to niche market, probably, being able to say, and I don't want to, we don't want to pit farmer against farmer. That's not the goal here. The goal here is to be able to differentiate. Everyone has a market, right? A lot of markets can be local, or they can be export markets. And so if you happen to be lucky enough to have a low clay soil, and you can document this through a traceability study, you'll have an additional market. The point is not to say that farmer D is better somehow than farmer B, because it's just the consequence of the natural environment in which they're operating, or at least a large part of this is. You see the rest of the bars are very, very similar. If we look back at the other impact categories, the top one is the one that's in the graph that I just showed. The land occupation is very similar. The fossil fuel depletion, of course, is very similar, right? They're operating the machinery in very similar manners. Eutrophication is about a factor of 2 difference, and it's probably got to do with the nitrogen cycling in the clay soils and more leaching that happens there. Water depletion, again, very similar, and acidification also very similar. So, just a couple more slides, and then I'll finish up. I want to circle back to this idea of natural capitalism, sustainability, and traceability. I think that some of the comments earlier about the traceability being a backbone is exactly the way I view it. And our ability to add on and get additional value from this traceability tool, I think is really quite impressive. The potential is really quite impressive. Resources are limited. We have to understand and document supply chain transactions, and we can enable identification of environmental hotspots that way, and enable identification of inefficiencies in the system, and we can also maintain food security and food safety. LCA, as I've mentioned and believe, is a tool that's very valuable in this space. It provides an opportunity to integrate across supply chains and provide a simpler way of communicating the complexities. And then the last bullet is again, the traceability as a backbone and the synergy that we can achieve through those. One thing that I wanted to mention to a question that was asked earlier about GMOs and disease, right? So if we have a GMO animal that doesn't get sick, what are the trade-offs? What are the benefits, right? So there's some public perception associated with GMOs that we have to address, and I think we can. The benefits from the environmental side can be quite tremendous, and LCA is a tool that will enable us to quantify what those benefits are. We have less use of antibiotics, and therefore less lowered chance of antibiotic resistance, therefore health benefits to humanity. We have, if animals are healthy, we know that their feed conversion ratio is better, and so healthy animals are also better for sustainability. We use fewer resources the healthier that our animals are. And so I think that this conversation around GMOs and sustainability is a really important one. So there's on the one side the social perception that GMOs are anathema, right? The folks in Europe don't want them in their supply chain. But there are trade-offs, right? There are impacts to the environment that accrue because of those decisions, and I think that we need to be able to have those conversations. And I'll close with the last slide, which is the one I hope you remember, life cycle thinking. So you don't have to be an LCA expert to understand LCA. You do have to be able to think broadly, think about the whole system. We don't need to optimize one piece at a time. We need to think about how the whole system interacts. We need to understand from cradle to grave. We need to recognize that it may be the case that a suboptimal system over here enables a greater overall optimum. We don't often think that way. We don't design things that way. Think deeply. What are the impacts? What are the effects? What are the consequences of the activities that we do? How much, right? And this is where the traceability and the information becomes very, very important. Being able to have access to and understand how much of this or that are we using. To think comparatively. What if we did it differently? What would be the effect, right? What if we do use GMO animals or we don't, right? What are the trade-offs? And then lastly, I think that the same thing that's been said many times already through the conference, transparency and traceability, documentation of what we do is really important, because at the end of the day, we only manage the things that we measure. And so we need to have measures and metrics, and we need to have a system by which those measures and metrics can be tracked and communicated to people who make decisions about what they purchase, right? Whether it's a mom at Walmart or Costco deciding which meat to purchase, or whether it's the government beginning to care about sustainability or sustainable procurement. So all of those things matter. And with that, I'll close and try to answer any questions. Questions for Dr. Thoma?
Dr. Thoma, thank you very much for a really exciting presentation. And I just want to make a comment, not the question necessarily. I'm now at the diagnostic lab at Cornell, but prior to that I was at Virginia Tech, and I built a public health program with a One Health focus. And yes, we look at our medical professionals and we look at our veterinarians, but I was looking for engineers like you to add that environmental component to this One Health umbrella that we are working on. So I very much appreciate what you have said. I was looking at engineers for the built environment, for systems thinking, and bringing them into the fold. And we, on the One Health side, have failed to do that right. So thank you much for...
I'll give you my card.
You pointed out a really fascinating thing when we hear about the gases that our beef animals are secreting into the environment. And your information is so exciting. I wonder, since all of the bison or the buffalo, what were there, 48 million estimated to be? They had to be creating an issue. And I've used that argument a little bit when people go to criticizing the cattle. What's your answer? How would you view that as being an effective way to say this isn't brand new?
So yes, I agree that buffalo are clearly ruminants, and they would have had enteric methane associated with their lives. I guess I'm not sure that is an argument that you could use to say we shouldn't be trying to do better in our industry, just because in the 1600s there were 40 million buffalo that were emitting the same amount of methane. I'm not sure that that's a an argument that would pass muster, for example, with EDF or World Wildlife Fund or some of the critics. Doesn't mean that it's not true. I think that it is, but we have systems that we're managing, and so I think that given that the emission of greenhouse gases is apparently affecting our climate, and I don't know if everybody. I don't know whether you go with the 97 scientists who say that it's anthropogenic or the 3% who don't. I believe that we, humanity, are having an influence, and that therefore whatever systems we are managing, we have some responsibility to try to improve. That's not a very satisfactory answer to your question, I'm sure, but I don't dispute the truth of what you say.
I would like your card as well. I would like your card as well, so don't run away.
All right.
My name is David Meeker, and I work for the National Renderers Association. And renders handle somewhere between 40 and 50% of every live cow, pig, chicken, and turkey that goes to market, and a few other species. We know that our activities elevate the sustainability of all of animal agriculture. We are having kind of a tough time quantifying that, and that's what I want to talk to you about. But, you know, we really need to get a handle on this, because vegetarian poultry diets and pet foods that go to human food and some other trends are really the opposite of sustainability, and we've got to use these byproducts for the highest possible use. So we need to talk.
Thank you.